there, ladies and gentlemen, watching the show of me doing stuff. This is Blend Miner. I'm doing a little dub on my own videos, might be kind of stupid, but some of you suggested me to do this, and I was like, yeah, it might be fun. I think I can speak English a little bit, so you can understand me good enough, and there might be another type of audience out there that wants to also know my videos, and I kind of like doing this, and I like English. So I was like, I'm gonna give it a try. So you can thanks Ian Apple for this. So he asked me, can some remake this in English? And I was like, sure, why not? I'm gonna try it. And he said them audio. I was like, Okay, so anyways, this is the video here. You can see it. I opened it in VLC Media Player, and I'm running it, and I'm gonna try and dub things as they happen. So here I'm gonna explain how meshes work, how they are created, how polygons. What are polygons? What is a vertice? What is a face? So it take this little cylinder as a capsule in this case. I deleted the cylinder. I'm gonna pause a little bit. You can see these little things here, these triangles. The whole mesh here is created of triangles. You can see one triangle there, and so on and so forth. Everything is here are triangles, and triangles, they face two ways. They face either forward or backwards. So what I mean by this is this little triangle here is only being rendered on this side. If you would watch it from the other side, it would be invisible, not even being there. So that's my point when I mean they only face two ways. So yeah, that's basically how meshes work. There are other types of meshes. They are quad, I think. Yeah, something like they're not, which are not made of triangles and of little, not cubes, squares instead of triangles, which I think for performance, in this type of game, would be better. But Unity just works with triangles, unfortunately, so that is not a choice we could choose. Yeah, you get the idea. So now I'm showing a cube, since a cube behaves in the same way. Every face needs two triangles. You cannot fit one triangle to make a face, unless you want to make a little trianglish world. So this is how we're going to render our chunk. Every block is going to have two triangles on each side, and they're going to be render them depending of what's on the side. If there was a block on top of it, we would not render this top face because it's not needed. So that's the idea behind mesh generation, and we're gonna do this by code. We're not gonna open any meshing programs or something, as you might have noticed on the tutorial as we progressed. So yeah, I'm rambling something, and here's me explaining it on Paint how we're gonna do this. So for each chunk, we're gonna have a position. Let's say 10 by 10 by 10, and we're gonna render those cubes off that location. It's gonna be very fun. It is. And so there's two things we gotta worry about mostly: vertices and triangles. Why? Because triangles are made out of vertices, and vertices, if you don't know already, it's kind of common knowledge, but hey, I'm teaching you this. Maybe I'm not a good teacher, but I'm gonna try and teach you this. what I was vertices, exactly. Vertices, or as many may call them, vertexes or whatever. I'm just gonna call them vertices. If you have any problems with that, just deal with it. They are like points in space. They are not any kind of 3D object, model, whatever. They're just a point in space. So if we want to render a face, just a front face. Sorry, my little sister just invaded my room. So I was talking about vertices. A triangle is made out of 3 points. You can see me drawing them here. 3 points. There you go. So let me go over this. Whew. We have here the first point. So if you want to render a face that is facing forward, I mean in the renderings. Wait, damn it. Yeah, that's my desktop wallpaper. When you're watching it from one side, you can see it, but if you watch it from another side, you cannot see it. So if we want to see it from like forward, the direction you want to see it, you have to make it like clockwise or counterclockwise. So if you go from point 1, 2, and 3, you would see the little triangle. Well, right now it's just 3 points in space. You wouldn't see anything. But if this was a triangle, you would see it. You would see it from the front. But if we did something like 3, 2, 1, you would see it from the back because it is counterclockwise. So that's how triangles work and the cooling and everything works. So yeah. And then I have a fourth point. For the 2 triangles, we're gonna use 4 points, 4 vertices for 2 triangles. Why is that? Because first of all, it's memory friendly. I mean, you don't need to have like 6 points in space to draw 2 triangles. We can just use the same point here to draw this triangle. So we're gonna go clockwise, I mean. So we go 1, 3, and 4 for it to render forward. That's as simple as it gets. That's how mesh creation works. That's how 3D programs work. Well, at the moment. So yeah, that is it. That's how mesh generation works. So basically, this is just me right now showing you how the triangles are gonna look when it's gonna be finished. So basically, to create the triangle, we just need to give him 3 points as an information, and the unity and the magic is gonna be done by itself, basically. Let me just go forward, just I'm rambling about not useful things. So yeah, I created a script folder. I'm gonna do another script called chunk. And yes, I am aware that I'm spelling chunk wrong. I'm very well aware of that, and I was when I created this video, but I like writing chunk like that. That's how I learned it. I don't want to change my writing thing. I like it like that. Alright, so in our public class, we're gonna create a variable, which I'm not sure it's gonna be. I'm just gonna wait for me to stop rambling about things and write it down. Okay, I remember now. I'm gonna talk about 3D arrays. You're gonna ask me, what is a 3D array? So this is a normal array. This is like a list of items. There are 2D arrays and 3D arrays. 2D arrays, they are arranged. Let me just open Paint a little bit. So 2D. Damn it. Okay, let's start over. 2D arrays, they are little chunks of information they have like a little X and Y positioning, kind of. For instance, let's say we create a new array. This is a 2D array. This is like just a way of me demonstrating it. It's not any kind of 3D or 2D imaging or something. It's just a concept, an idea. So this is a 2D array which has 4 by 2. So yeah, I was gonna write 4 by 2, but I forget. Yeah. So this little thing here would be 0, 0. This thing was 0, 1. Sorry, 1, 0, 2, 0. So it's just basically an array of items, but it is in a 2D format. And the 3D one works just the same, but it takes in 3 integers as coordinates instead of 2, which would make sense because it's 3D anyways. Yeah, so I'm painting and explaining things. So after that, we just go on and do a little public void start function, so we can reset our array, I think. And also we're gonna do a little width and height variable. Which is gonna be how many blocks the chunk is gonna have on the width, on the height. So basically, you can calculate how many blocks the chunk's gonna have by doing 20 times 20 times 10. So one chunk is gonna have this amount of blocks, which is crazy. Also, maybe for the people that don't know what is the concept of chunks, well, you can understand anyways later. I don't want to ramble too much on the video. So we're gonna do a little loop. We're gonna loop through all the blocks on the map, basically. So we start with 0. Here you can see x is 0. Then we do this loop while x is smaller than width, which will just go to 19 and then stop the loop on the x-axis, and then just add the little value. If you add 2 pluses in front of an integer, it just adds another value. It's the same thing as you do plus equals 1. So yeah, this is what I was talking about. We're gonna reset or set our little array. This 20 by 20, yeah, this is a mistake actually. This here should be replaced with width and this with height. So this is like the size of the array. So this is the size on the x-axis, this is the size on the y-axis, and this is the size on the z-axis. Alrighty. So we are doing an if check. So what I'm doing here basically is I'm setting some values for the map so we can use and try and create a mesh based on it. Oh lord. Okay. So we check like if the y-axis on the array is smaller than 5, then we set the value of that array to 1. By default, everything's going to be zeroed out. Every single slot on the array is going to be 0. So we're just going to set those little arrays to 1. So we have like a little map, I guess, drawn. It is a flat map. We're not adding anything, basically, just a little 4-block height thing. So we're gonna calculate the mesh with its own function. Why not? Because functions are nice and keep the code clean. We're gonna need like 3 or 4 variables. We're gonna add a little. I don't know how that is called actually. Never got into it. It's just so this script needs some component to be able to function. So in this case, I'm gonna use I'm gonna say that it requires a mesh filter on the object that is being attached to, and if it doesn't have that, it will just add that. So mesh filter, mesh collider, and what is the other one? Mesh renderer. There you go. So you don't really need to know what all these 3 do. Basically, the mesh renderer shows the mesh filter. I have no idea. The mesh collider just calculates the collisions for us automatically, so we don't have to struggle with that. So compile without any errors. We're gonna create a new empty object. We're gonna call it chunk. It's gonna be our chunk prefab. We're gonna add the chunk script to it, and you can see it added all those three automatically. You don't have to mess up with those. It's just, yeah, I'm gonna try like, yeah, I'm re-watching it because I want to see those three little components, so maybe I can explain to you what they do better. So mesh filter is basically the component that holds the mesh details, and the mesh renderer is just renders the mesh on screen, and you can choose if you want shadows or not for it, and materials it uses, and I'm changing the volume without wanting to. It isn't that important, really. So we're gonna save the scene, so we're gonna use it later. I mean, why not saving a scene? Add it to the build settings too. Just click add current and it's gonna go there automatically. We're gonna call calculate mesh on start function, so it gets called as soon as the object gets instantiated. We're gonna do a private mesh variable, which is gonna hold all the information we need. The mesh class is gonna hold the vertices, the triangles. They also have the normals, which can be calculated automatically by Unity, and so on and so forth. Also, we're gonna include or use the system collections that's generic on our little project, so we can use lists. And there you go, public list. Private list of vector threes, which is going to be vertices. So every single point in space is going to be a vector 3, of course. I mean, yeah. So you can notice here triangles, which I'm writing it in Portuguese, which is triangles, but that means triangles, is a int list. Now, why is that? How can an integer become a triangle? Well, that is a simple notion there, actually. I struggled myself when learning this. How some integers would matter. So we have 3 points. Point here, point here, point here. So this is 0. This is like an array of points. Point 1, point 2, and point 3. Since arrays always count 0 as a number. It starts with 0, it doesn't start with 1 as you would normally start counting 1, 2. You start with 0, 1, 2, 3, 4, etc. So then when adding our little triangles, we're gonna say we're not gonna say like a position like here, here, here. We're just gonna say that this little index. We're gonna say like add triangle, add a list to add add an integer to the list, and it's gonna be the 0 array, then 1 and 2 to go clockwise. It is a really simple notion. We're gonna try and explain a little better as we go on the tutorial. So we're gonna say the mesh that triangles, maybe not, okay. I'm trying to go on with the video. Do something, you stupid bastard. Yeah, so we're gonna say that the mesh on the start function is a new mesh, so we can use it because right now it would be null. We need to instantiate the mesh class first. Okay, so I'm going over some stupid things here. Oops. So on the calculate mesh, we're gonna add our vertices first because we need the vertices to be able to use the triangles. So the first vertice is gonna be at 0, 0, 0. So you can see that little point I did there is 0, 0, 0. Imagine a little 3D space on Paint, which is impossible because Paint sucks. But that's gonna be our first vertice. You can see I'm putting 1, but it actually corresponds to 0. So we need 4 vertices that we talked later. We're not going to use 6 because it's just a waste of memory and calculation time. So on our second point, we're gonna go on the x-axis, apparently -1. So the first little digit here is x, the second one is y, and the third one is z. This is always for vector free. So yeah, we're going -1 on the x-axis here, as you can see. And then we're going to reach this little point here. After we set this one and this one, we need to go on the -x-axis and the y-axis one little value. So that's what I'm gonna do. I'm gonna do to the left, go to the left and up. So we have this point here, and then to get the fourth one, we just need to go up once. So on the y-axis, we're gonna do 1. So I'm rambling again. So there you go. Yeah, you can see I have added 1 to the last vector. Now we're gonna go ahead and add our triangles. So there's gonna be 6 integers because there are gonna be 2 triangles, each one with 3 vertices linked to them. So in the first triangle, we're gonna go with 1. So we're gonna go 1, 2, 3. And then we're gonna go for the second one, 1, 3, 4, I think. Yeah, 1, 3, 4. So this is gonna be like the back face, I think, the way I'm doing it. So this is gonna give it an error. I don't know if I added like a -1 offset to it, since the vertices start with a 0 value and not 1. I'm wrong here what I'm doing. I don't know what I'm gonna do with it. Let's just keep on going. So we're now setting the mesh properties, the vertices to the vertices we just added here. We are transforming them into an array because they are a list, and the mesh vertices thing just wants an array and not a list. The same thing to the triangles. Then we're gonna calculate the normals and the bounds too. The bounds basically like the size of the mesh, and when the camera goes out of it, it just does not render the mesh. So Unity does that for you. Well, thanks Unity, I love you. There's also an optimized little function for the mesh. I don't know what it does. I just use it for the sake of it. I mean, it's an optimization thing. It's never that bad. Then we just set the mesh filter property to our new mesh that we just created and optimized. So let's see what we just created. So the script's compiling, everything should be fine. There you go. So we see nothingness and get an error. Failed setting triangles and instances are referenced. Yeah, that's my error. I just did 0 instead of 0. I started with 1 because I'm stupid. Exactly. I knew I was gonna set an offset. So yeah, -1 minus offset. That's basically what I'm gonna do. Yeah, my mouse was broken, so I'm acting all weird. So basically, to every single triangle, I'm gonna set minus offset. So everything should be solved now. Let's see what it did. There you go. You can see a little face there. That's the face we did. That's the back face that I was talking about. Because you can see it's being rendered on the other. So Z's forward, so we're rendering it backwards. So we get a little pink face. The reason it is pink because it does not have any material attached to it. So this is, I'm just showing the triangles thing, how they are going. So in wireframe mod, we can see our two little triangles, the first one and the second one. It is really nice. Alrighty, so we're gonna change the order of these little things, because we're gonna get the vertices that count. So we, like, every single time we add a little cube, it's gonna take the vertices that we had and just add this little offsets here. It's kinda, I mean, I don't want to rumble about it, it's just logical if you do it like that. Because if you... Damn it. Because if you had like two faces, let's see, the front face and then gonna add the back face, if you set here like 0, 1, 2, it is gonna reference the old face and not the new face you're gonna trying to add. So we just take the count of the vertices and we add it, so it gets to the index we want. That's as simple as it gets. Apparently, I want to make a little function for that. So add cube front face. It's actually the back face, but it doesn't really matter. I mean, yeah. So basically, we're gonna do a lot of functions for add cube front, up cube back face, the right, left, I already said back one, top and bottom. So we can easily like do and change our chunk to our likings. Just make our life easier, basically. So we're gonna review our little loop that we did on the start, but on the calculate mesh. So there you go, then just close those little two things. I just copied the same loop, so we don't have to rewrite it. So if map x, y, and z isn't 0, since we set some little values to 1 on the bottom, 4 rows of 1s, then we say that. So if the block on top of the one that we are at is 0, then we're gonna add the little cube face. But as we don't have the function yet, since we have only the front face and we want to do the top face, we're going to do the z plus 1. Actually it's minus 1 if I'm not wrong, but well, that's just me. So add cube front if the block in front of it is null. So we have a block. If it is not 0, if it is some kind of a material, then we check the block on front. If it is null, then we have to show the block to the player so he can see what's on there. But if the block on front is something else, then there's no need to render the block back. I mean, you get the idea. That's basically it. Is block transparent? So this little function just gives us the same thing that we did there, if the block is 0 or not. So if the block is not 0, then it will return true. So just copy what I'm doing. So we have to check if the x is bigger than width, because if the x is bigger than width, then we are getting out of the array boundaries. So we need to get back inside. But if we do get out of boundaries, we will get an index out of bounds, I think, or array something crazy like that, and we don't want that. So if we are getting out of the boundaries, getting bigger or smaller than the numbers inside the boundaries, we return true, which is 0 in this case. Otherwise, if just return the map. If it is 0, return true. Otherwise, return just false. As simple as that. So just replace the little map thing with is transparent and the coordinates we set. Right now we should not get the same error because we are checking between the boundaries. So arrays out of index or out of range should not appear in the console. And on the add log from, we're gonna add some coordinates, so we need to set the position of the face, otherwise it will be all just zeroed out. And then we need to add the offset to the vectors. So instead of 0, we say x, and we also this part is not needed. This will give you just problems, so don't do this. This was me being stupid at the moment, because I forgot. When you do 0, 0, 0, you're talking about the coordinates locally. So if you have a little object as, I don't know, coordinates 2050 and 3, and you say you want to add a face at 0, 0, 0, it will add those coordinates and not at the world coordinates. So that's just my mistake. So I was just explaining there what Martha float wind does. Basically, it transforms float into an integer. A float is a number with decimals, and an integer is an entire number without decimals. So it's just easier to work with non-decimal numbers than with decimal numbers. So here just z. Yeah, this is what you gotta do. This is not what we gotta do. This is wrong. Don't add these 3 lines here. Just don't. So just add for every x coordinates x plus and the coordinate we set. For the y coordinates y plus the coordinates we set, and for the z z plus the coordinates we set for each one of them. Just like that. What a wonder. Just beautiful, magnifique. So now we should actually see the faces popping out, popping onto existence. Okay, so we're getting again the index out of range exception. This means we're getting out of the bounds of the array. I don't know why that is. We're just gonna go ahead and see what I'm gonna do to fix this, and I'm gonna explain you why it helped and why there was a mistake. So I'm just going through the code here in the real video, in the not dubbed version. Yeah, apparently that was my mistake. So not plus, it's if it is bigger or equal, because if you check just if it is bigger than 20, then 20 is going to be a valid number, 21 is going to be an invalid number, if you know what I mean. So you can see a face there. Now what a wonder. So our little faces, there should be like 4 little blocks there. They are pink at the moment. We're gonna change that in the new tutorials. So they are beautiful, aren't they? This is the beginning of a huge era. It is, trust me. And that's 5 blocks high because 0 counts as a number. I'm so stupid. I keep like changing these things. Yeah. So yeah, right now I noticed that this front face is actually at the back face. So what I'm gonna do here is I'm just gonna switch the triangles to counterclockwise. So 1, 2, 3 is clockwise. To switch them up, you just gotta change the 1 to 3 and the 3 to 1, and same thing 1 to 4 and 4 to 1. Just switch those two numbers on top and on the bottom, and they will go. They will switch off sides. They will render on the wrong side. Damn it, right side. Alrighty. So now it should work just fine. If you go to the scene, it is rendering on the right direction. I finally noticed my mistakes. So you can see the little pivot point is not aligned to this little thing here. That's because of the thing I told you to not write. So if you don't write that, this should be like aligned to one of the corners. So keep it aligned to the corners. Don't make it a world coordinates, because that would give you something not right. So we're gonna just copy the function and do like a little backface function. So on the backface function, we're just gonna switch again the triangles to counterclockwise, so as it was before. Just switch the numbers on top and the bottom of those three little values. And if the block on z-1 is transparent x, y, and z-1, then just add the backface, as simple as that. And we're gonna repeat the process for every single face, which a cube has 6 faces, if I'm not wrong. Yeah, 6 faces. So if you check this out now, you should have 2 walls, 2 pink walls on both sides. So there you go, we have 2 pink walls on both sides, the front and the back face. So you can see, because we do the little check if the z plus 1 is transparent, it does not show the faces that are inside the thing, that are not supposed to be there. So you can see our first chunk is starting to get very nicely done and beautiful. Well, if you like pink, it is beautiful. So we're gonna do the other faces, which is gonna be the front face, nope, the top face. That was just me guessing. Alright, so the top face. For the top face, we're gonna do something nicely different. We're gonna have to change the vertices coordinates. So this is how you see it from the front. But if you do it from the top, it's the same concept, but a little bit different. I'm getting kind of fatigued to explain it, but I'm gonna try and do it. Anyways, so we have to go like 0. I'm gonna start on the y-axis 1. Okay, that was bad of me. Sorry. So all of the points are on the top now, since we added plus 1 on the y-axis, every single one of them. Then we go to the left. I'm doing this backwards again, I'm so stupid. Then we go forward, which is plus 1. So we need the corner, so we do minus 1 on the x-axis, go to the left and in the front, and then just on the front. It's the same concept as we did before, but with different coordinates. Instead of going on the y, we go on the z and x. So if the block on top, I think, is transparent, then as the block. So y plus 1 to be on the top, so we go 1 unit higher. So we should not see the top face. Actually, we'll see it backwards because I'm a stupid little fellow. And I switched again the coordinates for the vertices. Oh no! Well, I'm not that stupid, I think. So yeah, I set to the right indexes for the faces, so we can see a little top face. And I'm gonna end the tutorial here. We're gonna continue this in the next episode. We're gonna add the other faces, and probably gonna start adding a little material to the chunk, and maybe introduce UV coordinates, which is as simple as the triangles are. So if you didn't understand something, or you want something to be explained a little bit better, just ask in the comments below, and I will be glad to answer. And with every single new comment, I get more motivated to continue this series. So yeah, thank you for watching, and I love you guys. So see you later, baby.